project that we're talking about today is where we were looking at fungal virulence genes, and there was a gene that was identified in a fungal pathogen of maize, of corn, and we found the similar gene in the valley fever fungus. What we found when we deleted it is that the Delta CPS1 strain was completely avirulent, unable to infect any mice. So this strain that we created functions as a live attenuated vaccine.
Our involvement with Anivive started when we applied for a grant to take the Delta CPS1 mutant strain of Cocci, which is avirulent and also showed profound efficacy at preventing valley fever in mice that would otherwise die from it within a couple of weeks.
This vaccine, which will be relatively inexpensive, will allow dog owners to have peace of mind that their dogs will not end up getting valley fever and going through the suffering that dogs go through or the economic costs for treatment of the disease.
And the reduction in economic burden on dog owners in endemic states is going to be more than $20 million a year that they spend diagnosing, treating, and following up on valley fever. And then in terms of humans, complicated Cocci in a human over their lifetime, because many of them need care for the valley fever or they're disabled for their entire life, can be millions of dollars per patient.
Tech Launch became involved in this project when we realized we had something that was highly beneficial. We worked with Todd McCauley both on the invention disclosure and then writing the patent. And Tech Launch was then involved in working with Anivive to have them license the patent.
We really thank Tech Launch for awarding this to Anivive as a relevant company that's made a big splash recently. And we thank you very much for considering the Anivive and Valley Fever Center partnership and ACBS that led us to where we are, and it shows the strength of collaboration between the departments within a university and also between the university and enterprises within the community.